The 1970s marked the assimilation of the personal computer into the lives of American people. With the introduction of the personal computer, lives in America were greatly changed through better access of information, better performance of many jobs, and better social connections. However, the technology needed for the computers of the 70s came about much earlier. Early models of the computer-like technology included the German Enigma from World War II, the Colossus designed by British mathematician Max Newman, the ENIAC built in 1945, and the base foundation of random access memory technology used today, the Manchester Baby.
Introduced in the 1920s, the Enigma wasn't popularly used until World War II to decipher German war strategies. The Polish were the first people that learned how to decipher the German war codes before the start of World War II and the early dates of the war. In the winter of 1932, the Polish Cipher Bureau successfully broke the first code. 5 weeks before World War II, the Polish introduced their idea of the Enigma to the French and British delegates in the Warsaw. Later, the United Kingdom designed their own model based off of the work of 3 Polish mathematicians. Afterwards, the Enigma was continuously modified to acquire more advanced features. New models of the Enigma were unable to have more applications in wartime situations. New uses included locations of submarines, information on bombing raids, movement of military battalions, and locating supplies. Now known worldwide due to its success during the war, the technology behind the Enigma began to spread to other countries. The Enigma is the basis of the technology that the computers of the 1970s used. It introduced a new type of user input that the world had never seen before, which allowed people to do tasks that were difficult and tedious to do otherwise.
Invented by Max Newman in 1943, Colossus was dismantled and shipped to Bletchley Park and assembled during December 1943. It became operational in January 1944, where it had its first successful test decipher of a code. The Colossus enabled codes to be deciphered in just hours as opposed to weeks done by its counterparts. It was introduced to the war just in time to be able to decipher a message that gave important information to Eisenhower right before D-Day. The message included information regarding the whereabouts of Hitler's infantry and panzer divisions. Shortly after the development of the Mark I Colossus, the Mark II was then developed in June 1944, in order to handle the increased number of messages. By the end of the war, over 63 million characters of high-coded German messages had been deciphered. This was quite a feat, considering the Colossus was only run by 550 people at Bletchley Park. In order to function, it read characters in the International Bordeaux Code. It had max speeds of reading up to 5,000 characters a second. The Colossus utilized circuit technology, which was still used in today's computers. Overall, the Colossus showed the success of the circuits in computers. Because of that success, circuits were used in future technology similar to that of the Colossus.
During World War II, technological advancements were prevalent throughout the United States. The radar, the ENIAC, and the Enigma were just a couple of the incredible advancements that aided the United States during the war. However, the ENIAC was by far the most advanced because of its sophisticated assembly. The development of the ENIAC was provoked by the war efforts of other countries. Fearing the inevitable entry into the European War, the U.S. found it necessary to improve previous technologies. America turned to old technologies to produce computers in hopes that they would aid them in the war. The ENIAC performed many basic functions of the 1970s computer. The primary function was to be a test computer to determine what kind of technological power the U.S. held at the time. Since abaci were the leading form of mathematical calculations, the U.S. saw that they needed a new, faster, and more powerful tool to compute the necessary problems of the war. The ENIAC was the first of its kind that was able to do simple mathematical calculations on its own, including multiplication, division, square roots, addition, and subtraction. One of the main technologies used in the ENIAC can be compared to the central processing units that power modern computers today. This level of computing power was applied to the solving of atomic energy problems during the creation of the atomic bomb in the Manhattan Project. It also computed ballistic trajectories, problems pertaining to weather conditions, and aided in the development of wind tunnels. The ENIAC's design proved to be the basis of other processing computers such as the EDVAC, ORDVAC, UNIVAC, and SAC. Although the ENIAC eventually became obsolete, its ideas and functions can be found in computers today everywhere.
Developed as a means of a storage mechanism, random access memory was developed in order to advance the computer enough so that it could perform multiple functions at the same time. The Manchester Baby, as it was called, was so successful in its operations using the RAM that the creator of the computer developed the Baby into a full-sized machine, the Manchester Mark I. The UK government then immediately contacted Ferranti Ltd to build a commercial machine based on its design. The race to build the storage program computer was won by the university projects in the United Kingdom, at Manchester and Cambridge universities. The design was based off of the EDVAC, which in turn was based off of the ENIAC computer system. Manchester had a design that was all their own, and they were working with their simple storage mechanisms. In May 1945, the computer was finally finished. It included a paper tape input and output, and a delay line. However, it failed to include any means of backing storage. The model continued to evolve from the Baby and had pieces being added over time. In October of 1945, the computer was finally fully operational, and now included a back storage system called Random Access Backing Storage. The US at the time had its own program attempting to develop a storage system. The program made many different models, all of which had some form of storage program capability, but did not have the ability to store a program in RAM. The Harvard Mark III, completed in September of 1949, did not have actual RAM. However, it had magnetic drums that acted similar to RAM. A computer with this form of functionality was developed for the US Air Force, but contained many reliability problems, which crippled its usefulness. It was not until 1951 that the first commercial production computers appeared. Even though these computers were not for public use, they marked the start of commercial sales of computers. The sales of the computers were aimed at the scientific community, rather than the public market. This is because the computers were so large and cumbersome that they were illogical to have in a home. Due to these advancements, Remington Rand decided to design and build a computer for general, public, commercial, and industrial usage. The EDSAC computer was produced for in-house use and business use, however, it was so successful that it resulted in setting the foundation of public computer sales.
Calculating devices do not eliminate learning. They only do what they are told. Students must completely understand the logic of problem solving and be able to provide the correct set of instructions. In addition to
During the 1970s, many companies successfully developed hardware that is still used today. Intel developed a new random access memory chip capable of holding 1,000 bits of information in the 70s and introduced the first microprocessor, the Intel 4004, in 1971. Computer pioneer Douglas Engel patented the first computer mouse in 1970, while Xerox released the first laser printer in 1971. Toshiba then announced the first floppy disk drive in 1974, with the first 5.25-inch floppy disk invented 2 years later. One of the earliest and most popular computers during this time was the Tandy Corporation TRS-80. With the keyboard and motherboard in one, it set the trend for computers to follow later on. With a memory space of only 4 kilobytes and a processor speed of only 1.77 megahertz, it transformed the microprocessing era forever. After the arrival of that processor, many different computer companies appeared and began to develop their own microprocessors and microcomputers. Companies like Apple, Compaq, and Commodore started during this period. The first home computer came in 1981, developed by IBM.
The computer-like technologies of the early 20th century paved the way towards great technological achievements throughout the United States. The personal computer of the 1970s was influenced by the Enigma, the Colossus, the ENIAC, and the Manchester Baby, all of which contributed vital parts to the modern personal computer. The Enigma, while weak by today's standards, was the leading computer technology of the late 1930s and early 1940s. The Colossus led the way to modern circuits and proved how unnecessary vacuum tubes had become in technology. The ENIAC was the first of its kind to have any sort of computing power. The computer was then able to do mathematical equations involving addition, subtraction, multiplication, division, square roots, and function tables. This set the stage for future computers with similar processing power. Lastly, the Manchester Baby was the first computer to have any form of random access memory. This allowed the computer to do multiple functions at the same time and also allowed computers of the future to do the same. These ideas and models were all combined into the personal computer of the 1970s and late 1980s. The introduction of the personal computer into American society forever changed our culture. Now, with this technology, we were able to have greater computing power. The computer aided the economy during the 70s because it became so popular, and at a price of $600, people around the country wished to own one of the TRS-80s, the first form of the personal computer to hit the market in the mid-70s.